Hello, Calculus. We are in the last lesson of Unit 1 today, so this is Section 1.3c, Intermediate Value Theorem. I'm going to force a pause on your screen, make sure you've got everything on the checklist, including making sure that you are in full screen mode. Alright, so you don't need to write anything yet. Let's just go ahead and read what the Intermediate Value Theorem says. We call it IVT for short. So Intermediate Value Theorem says that if you have a continuous function f of x, on an x interval, so closed interval from a to b, then f has to attain every single y value between f of a and f of b. So this is really just a continuation of continuity. It's really just saying you can't have any skips. So every y value between your endpoints has got to be covered. Okay, so here's what I'd like for you to write down. The hypothesis of IVT is that f is continuous on a closed interval. Okay, and we know what continuity is. Closed interval means that I'm including my endpoints. Okay, so my endpoints have closed circles as opposed to open circles. Okay, if that's true, the conclusion is that every y value between f of a and f of b is covered. Okay, so let's take a look at these three graphs. I've called them my Roman numeral 1, 2, and 3. So if I take a look at the first graph, is the hypothesis met? Well, is f continuous from a to b? Yes. And on a closed interval? Yes. Okay, so I'm including a and b. Okay, so hypothesis is met. Is the conclusion met? Well, let's see. Let's look at the y value here and here. So are all those y values covered by the red graph? Yes, they are. So hypothesis is met and conclusion is met. Okay, I'm going to force a pause on your screen. You try 2 and 3 for me. Okay, so for 2, is the hypothesis met? No, it's not, correct? The function is not continuous. Is the conclusion met? So here's the y value at A, here's the y value at B. Are all these y values covered? Not quite, right? We've got a problem for that y value, okay? So conclusion is not met either, okay? That last one, is the hypothesis met? Hypothesis is not met since the function's not continuous. I've got to jump around here, correct? Is the conclusion met? Well, let's see. Here is the y value at A and the y value at B is there. Are all these covered? It actually is here, right? So if the hypothesis is met, like in graph 1, we have to have the conclusion, okay? That's what a theorem says. If this, then you have to have this. Now, if we don't have the hypothesis, it could go either way. We don't know. We may have the conclusion, like we did in this last example, or we may not, like we did in the middle example. So these types of problems appear quite a bit in the free response section of the AP exam, and this is how they'll ask it. They'll say, does the data support the conclusion that f of x equals n, where n is some number, for x between a and b? Justify your answer. Okay, and then what you write is this. So I'm going to force a pause on your screen, and I'd like for you to write this part, okay? If my little word bubble covers all of your screen, just go ahead and hit continue and pause for me again. All right, so what we write is yes by IVT, since f is continuous and n is between f of a and f of b. Okay, and we're going to practice this. But 3 pieces, and we need these 3 pieces anytime we use a theorem for a justification on the AP exam. So my first piece is I state the theorem I'm using. My second piece is stating why I can use that theorem. So remember, the hypothesis for IVT was that f is continuous. If it's everywhere continuous, it's certainly continuous on the closed interval. And then the last part is just showing the math, okay? So state the theorem, state why you can use the theorem, and then show the math. You can do those in any order you want. I tend to kind of list them in 3 lines like that, but you can write it in all one sentence. As long as those 3 pieces are there, you're good to go. All right, I'm going to force a pause on your screen. Can you please write that f of 2 is 3, f of 4 is 7, f of 5 is 1, and that this part is what we're trying to show. Okay, so we know that f is a continuous function, and we want to know if f of x is 6 for some x between 4 and 5. Okay, so let's check the math first. Let's find f of 4. Well, f of 4 is 7, and f of 5 is 1. So is this number 6 between 7 and 1? Yeah. Okay, so here's how we're going to say it. We're going to say yes. By what theorem are we using? IVT. And we need to state why we can use IVT. And they told us that f was continuous. So since f is continuous, and then we show the math. So I like to start with the number I'm trying to prove exists, in this case 6. So 6 is between 7 and 1, the 2 given y values there that I boxed. So I'm going to put 1 here and 7 here. And then 7, if we come back here, is f of 4, right? And 1 was f of 5. So this is how our final statement looks. Some people prefer this. F of 4 is 7, which is greater than 6, which is greater than 1, which is f of 5. Either is fine. You're making the same statement there. You don't need both, but either is fine. Just make sure that, of course, your inequalities are facing the correct way. All right, so I'm going to force pause on your screen. Go ahead and write f of x. And then we want, does f have a 0 in that given interval? All right, so we want to justify an AP style. And remember, a 0 is when y is 0. Okay, so I'm going to find f of negative 2. So f of negative 2 is negative 2 cubed plus 3. So negative 8 plus 3, which is negative 5. Then we're going to find f of positive 2 as well. So I'm checking, like, this is my A, this is my B. So f of positive 2 is 2 cubed plus 3. So 8 plus 3, which is 11. Okay? And we want to check for what y value? Yeah, we want to check for 0. Okay? So take a look at the 2 y values we have. We have negative 5 and 11. Is 0 between those two? Yes. So the only thing left is, do we know that f is continuous? We do, since f is a polynomial, right? So yes, by IVT. So there's part number 1, state the theorem. Then we need to state why we can use the theorem. So since f is continuous, and then we'll state the math, right? So what y value are we trying to prove exists? 0. 0 is between what 2 given y values that we found? Negative 5 and 11. Negative 5 was f of negative 2. And 11 was f of 2. And that's it. So just make sure that your concluding statement has f of a and f of b in it. All right, so as a conclusion, I have some different types of real-life functions, and what I would like for you to do is decide if these are continuous or not, so if IVT applies to them or not, and I'd like for you to bring these to class, and we will discuss in class. So you can just call them A, B, C, D, and E, and decide yes, continuous, or no, not continuous. All right, you all, I will see you next time.